Hello viewers, welcome to Postgraduate Diploma in Environmental and Occupational Health. Today we are going to discuss about the course MEV 004 Environmental Toxicology. I am Professor Rupani. I would like to give some of the important features of the chemical toxicants today. So before going into the details of this program and then course, especially the topic that is chemical toxicants, we have to understand what you have studied in the previous class. So in that you have learnt about the various toxicants and their mode of action and also the sites of action. So we have also learnt about the routes of exposure through which the toxic substances can enter our healthy body. So the toxicants that can be absorbed and distributed and also stored in various tissues and also organs of the human body. If the toxic substances which are not detoxified are biotransformed, so they can remain in the organs of our body that causes the organ failure and also sickness, or otherwise we can call it as disease. So we are exposed to agents in the environment. That agents may be chemical, may be biological, or some of the toxicants that can harm our health. For example, we are exposed to particulate matter, the air that we breathe every day, or many different chemical and biological contaminants in water and food we consume. So almost everywhere and in all our activities through many other sources, we are exposed to the substances that can impact our health. So everyone, we have realized that health is wealth. Although all of these are potentially harmful, that means it depends upon the amount that we are exposed to, and this exposure of human beings as well as the other organisms to these type of toxicants result from many activities. So the intentional ingestion, unknowingly we can have this one, or otherwise sometimes it may be from the occupational exposure, environmental exposure, and also the either by the accidental or otherwise sometimes it is intentional poisoning. So today is the chemical toxicants topic we have to discuss. So what are chemicals? So they may be in many ways, that means they may be reactants, they may be solvents if we are working in the laboratory, and then catalysts, inhibitors, and also some starting materials and some finished products, that means the end product, or sometimes it may be a byproduct, contaminants, or of specialization of the products. So they may vary from the pure single substance to complex as well as the proprietary formulation sometimes. So exposure to these chemicals normally involves the solids, or otherwise sometimes liquids, or sometimes airborne matter, that is just like mist, aerosols, dust, fumes, and there are so many various forms, or sometimes it may be gaseous forms, that is vapors, in any of the combination. So many situations, for example exposure to welding fumes or to combustion products from the fossil fuels. So they may have the mixtures of both the chemicals and also the physical forms. So the quantification of this exposure is very difficult in that way. So an exposure to a specific chemical which is relatively low concentrations over a period may result in chronic effects, or sometimes at higher concentrations, that means the quantity is more, the effects may be acute. So some chemicals, they may produce local damage at their point of contact with our body, or sometimes it may have the entry into the body, and some other chemicals, they produce systemic effects. So systemic effects are, they are transported within the body to various organs before exerting an adverse effect. So that means once it enters into the body, definitely it will contaminate, or it will harmful, and also it will create some disease or sickness to some other organs of our body. So the toxicity of a chemical is the ability to damage an organ system. So organ systems, there are so many, are there kidneys, liver, and also they have damage and the disturb a biochemical process like the blood forming procedure, or it may damage the cell function at some site which is removed from the site of contact. So, any substance, even water, that can be harmful to living things under the right or the appropriate conditions. So, the chemical toxicants, they are categorized under several classes which are based on their chemical composition and their mode of action, but the broad classification of chemical toxicants is the exposure classes, and the second one is use classes. So, depends upon the number of toxicants, that means there are enormous number of toxicants are there. So, it is very difficult to classify them either chemically or by function or by mode of action, because there are many of them would fall into several classes. Some may be natural products. So, many are synthetic organic chemicals, and also they are using in the society everyday life, and some are byproducts of the industrial process and waste disposal. So, it is useful to categorize them according to the expected routes of exposure of or otherwise according to their uses. So, as far as our syllabus is concerned, so the categorization of chemical toxicants into two groups. The first one is exposure classes. So, the second one is use class. In the exposure class category, especially the toxicants which are, that means where we are exposed to the toxicants. So, they may have, that is food, air, water and soil, and also toxicants which are characteristic of the domestic and occupational settings. And the second one is use class. The use class means, that means we are using, for example, drugs of abuse, therapeutic drugs, agricultural chemicals and food additives, food colorants, and also the contaminants, metals, solvents, combustion products, cosmetics for that matter, and also all these are toxins, that means we are using. So, some of these like combustion products which are the use processes rather than being use classes. So, first we have to discuss in detail about the exposure classes. So, the toxicants which we are categorizing in this class, which are present in domestic as well as the occupational environment like food, water, air, soil. So, first we will see that air pollution. We have studied air pollution in detail in previous classes, but it is probably occurred as soon as the humans started to use the wood fires for heat and cooking. For centuries, fire was used in such a way that living areas were filled with smoke. After the invention of the chimney and the combustion products and the cooking odors, they were removed from the living quarters and they vented outside. But later on, when soft coal was discovered and used for the fuel, coal, smoke, and then these became a problem in the cities. So, gaseous air pollutants also there. So, these substances in general, they are gases at normal temperature and pressure, and also vapors once it is evaporated from the substances which are from the liquid or solid. So, out of these pollutants, the greater concern are carbon monoxide, hydrocarbons, hydrogen sulfide, nitrogen oxides, ozone and oxidants, sulfur oxides and carbon dioxide. Especially these are the most important and then toxic gaseous pollutants. So, the pollutant concentrations, that means any of these gases concentrations are usually expressed in micrograms per cubic meter, or for gaseous pollutants as parts per million by volume, in which 1 ppm, that is a parts per million, is equal to 1 part pollutant per million parts of air. So, particulate pollutants, they are fine solids, they are fine liquid droplets that can be suspended in air. If you will look into the sources of air pollutants, there are natural pollutants are there, anthropogenic pollutants are there. If as far as the natural pollutants are concerned, they may exist from the eruption of the volcano that emits particulate matter as well as gaseous substances like sulfur dioxide, hydrogen sulfide and methane. And these clouds may remain airborne for longer periods normally, And the other natural source is the forest fires. It will also produce large quantities of pollutants in the form of smoke, and then unburned, that is hydrocarbons, carbon monoxide, nitrogen oxides, as well as ash. And some natural sources are dust storms. They are also common source for particulate matter, especially in many parts of the world. And also the oceans produce aerosols in the form of salt particles. Plants and trees, for that matter, are major sources of the hydrocarbons of the planet. And also the blue haze that is so familiar over forested mountain areas where we will see with our naked eye is mainly from the atmospheric reactions with the volatile organics which are produced by the trees. So, plants are also produce pollens as well as the spores that can cause respiratory problems and also allergic reactions. So, next we will see the anthropogenic pollutants. So, these substances, they will come primarily from three sources. The first one is the combustion sources that burn fossil fuels for heating as well as the power generation, or sometimes it is exhaust emissions from the transportation vehicles and also the gasoline or the diesel fuels. And the second source is the industrial processes, and the third is mining and drilling. So, the principle that is the most important pollutants from this combustion are fly ash, smoke, sulfur and nitrogen oxides and carbon monoxide and carbon dioxide as well. So, the combustion of coal and oil, both of which contain significant amounts of sulfur. So, obviously they will yield large quantities of sulfur oxides. The most important effect of the production of sulfur oxide is the formation of acidic deposition. Normally we can call it as acid rain. If suppose nitrogen oxides are there, they are formed by the thermal oxidation of atmospheric nitrogen at higher temperatures. So, almost all combustion process that will produce nitrogen oxide. Next we will come to the water and soil pollutants, that means the chemical toxicants which are present in the water as well as the soil as pollutants. So, 3/4 of the earth's surface is covered by water, that everyone know about it, and also much of the remainder which is covered by soil. So, it is not surprising that water and soil that serves as an ultimate sinks for the most of the anthropogenic chemicals. If you will see the source of water and soil pollutants, they are mainly contaminated by the point or non-point sources. For example, an effluent pipe from an industrial plant or sewage treatment plant is an example of point source. So, a field from the pesticides and also the fertilizers which are carried by the rainwater into a river is an example of non-point source. So, the industrial waste probably constitute the greatest single pollution problem in soil and water. So, these contaminants like organic waste, like solvents, inorganic waste like chromium, and there are many chemicals, unknown chemicals are also there as an toxicants. So, the contamination of soil and water that results when byproduct chemicals are not properly disposed of are the most concern. So, in addition to these industrial accidents that may lead to severe local contamination. So, the examples of metals which are environmental concern, and these are also categorized into three classes, that is metals which are suspected as carcinogens, and the metals that move readily in soil, and metals that move through food chain. So, in those metals, some metals today we will discuss as toxicants. First example is, I would like to give that lead. So, it is a heavy metal of the greatest concern for health with regard to drinking water exposure. So, and especially the lead and arsenic are most important. The sources of lead in particular is drinking water. They are most important are from lead pipes as well as the lead solders. And also of concern is the seepage of lead from soil contaminated with the fallout from the leaded gasoline as well as the seepage of lead from the hazardous waste sites. So, lead poison, especially it is common in children, particularly in older housing units and inner city dwellings. in which children may consume chips of lead contaminated paint. And next is arsenic. So, drinking water is at risk for contamination by arsenic from the leaching of inorganic arsenic compounds normally used for the pesticide sprays from the combustion of arsenic and the arsenic containing fossil fuels, and also from the leaching of mine tailings as well as the smelter runoff. And the next metal is the chromium. If you will go for the effects of this arsenic, that is a chronic high level exposure can cause the abnormal skin pigmentation, or otherwise it may leads to the hyperkeratosis and also nasal congestion and also abdominal pain. At lower levels of the chronic exposure, cancer is the major concern. And epidemiological studies that have linked chronic arsenic exposure to various cancers like skin, lung as well as the lymph glands. And another metal is the cadmium. It is also one of the most significant effects of metal pollution is that aquatic organisms that can accumulate metals in their tissues that leads to increased in concentration of the food chain. So, the concern about long term exposure to cadmium, that is after recognizing the disease, that is itai, that means it is very painful, that means painful, normally we can call it as in certain areas of Japan. So, the disease is the combination of severe kidney damage and also painful bone and joint disease that occurs in areas where rice is contaminated with high levels of cadmium. So, this contamination obviously resulted from the irrigation of the soil with water containing cadmium, which is released from the industrial sources. So, cadmium toxicity in Japan has also resulted from the consumption of cadmium contaminated fish, that is a marine food. So, that taken from the rivers which is nearby the smelting plants. And another important metal which causes the toxication is the mercury. In Japan, everybody studied in schooling also. In 1950s and 60s, waste from a chemical as well as the plastic plant containing the mercury, they were discharged into Minamata Bay. So, the mercury that was converted to the readily absorbed methyl mercury by bacteria in the aquatic sediments. So, consumption of fish as well as the shellfish by the local population, which resulted in numerous cases of mercury poisoning. So, or otherwise this can call it as a Minamata disease. By 1970, at least 107 deaths that had been attributed to mercury poison and also 800 cases of Minamata diseases were confirmed. So, even though the mothers appeared very healthy, many children or infants born to these mothers who had eaten contaminated fish which is developed, that is a cerebral palsy like symptoms and also the mental deficiency. And some other sources, that is a pesticides. So, they are also major source of concern as water and soil pollutants. So, because of their stability as well as the we can say that there is a persistence, the most hazardous pesticides which are normally organochlorine compounds like DDT, that is 1,1,1-trichloro 2,2-di 4-chlorophenyl ethane, and also aldrin, dieldrin and chlordane. So, these persistent pesticides, they can accumulate in food chains, for example shrimp and also fish, that can concentrate some pesticides as much as 1000 to 10,000 fold. So, this accumulation normally we can call it as bioaccumulation. So, it is also well documented with the pesticide DDT. So, that is why it is now banned in many parts of the world. So, in another view, the persistent insecticides, the organophosphorus pesticides, like examples are malathion and also carbamates and carboryl compounds, and they are very short lived and generally persist for only few weeks to few months. And herbicides are also there because of the large quantity are using, and they are also of concern for the potential toxic pollutants. And next is phosphate detergents. We never imagined that, but it is another source of phosphate. So, that is received much that media attention in recent years. So, the increase in the nutrients and particularly phosphates is of the environmental concern because excess nutrients that can lead to algal blooms or eutrophication. Normally we will see in lakes, ponds, estuaries and also very slow moving rivers. So, these algal blooms that reduce light penetration and also that restricts atmospheric reoxygenation of the water. And nitrates are concerned, there are two potential adverse health effects from the nitrates in drinking water. One is the nitrosoamine formation and the second is the methemoglobinomine. So, if the effects of nitrates in drinking water is concerned, there are so many problems are there with the formation of the complex chemical metal complexes and also the nitrosoamine formation is most important. So, these ingested nitrates that can be converted to nitrites by intestinal bacteria. So, after entering into the circulatory system, nitrite ions which can combine with hemoglobin, they will form the methemoglobin. So, decrease in the oxygen carrying capacity of the blood and also resulting in anemia, or normally we can call it as a blue baby disease. So, it is particularly severe in young babies who consume water and milk, that formula which is prepared with the nitrate rich water. And next common source is the oils as well as the petroleum. These are ever present pollutants in the modern environment, whether from the used oil of the private motorists or the spillage from the oil tankers. At sea, oil slicks are responsible for the deaths of many birds. Very few birds that are badly contaminated will recover even after de-oiling as well as the hand feeding. So, oil is deposited on rocks and sand of course, and also preventing that beaches from the usage for the recreation after costly cleanup also. Some shore animals like crabs, shrimp, mussels, they are also affected by the toxic hydrocarbons they ingest. So, now we will see that what are the occupational toxicants. So, the goal of occupational toxicology especially is to ensure work practices that do not entail any unnecessary health risks. So, for that it is necessary to define suitable permissible levels of exposure to industrial chemicals using the results of animal studies as well as the epidemiological studies, so that at least we can have some remedies for this one. So, mitigation measures can be done on the basis of these epidemiological studies. So, these levels can be expressed by the normally the threshold limit values. So, that means airborne concentrations of substances that represent conditions under which it is believed that nearly all workers in any of the occupation may be repeatedly exposed day after day without adverse effect. Another measure is biologic limit value. That represents normally the limits of amounts of substances are their adverse effects to which a worker may be exposed without any hazard to health or well-being, that is determined by the measuring the workers tissues or fluids or exhaled breath, and also changes in the amount of some critical biochemical constituents and changes in the activity or critical enzyme, and also some changes in the same physiological function. So, the measurement of exposure, that means they may have sometimes made by the determining in blood, urine samples or hair samples or nails or body tissue and also some fluids. So, the amount of substance to which the worker was exposed and the determining the amount of metabolites of the substance in tissues or fluids, or determining the amount of substances in the exhaled breath. So, now we will see that these many toxicants are there, how we are encountered with the toxicants. So, we have to see that routes of exposure. So, the principal routes of industrial exposure are the dermal as well as the inhalation, that means the contact with the skin. So, Occasionally we will see that toxic agents may be ingested. If food or drinking water is contaminated, unknowingly if we will consume, they will enter into our body. So exposure to the skin normally leads to the localized effect that is known as the occupation dermatitis, and also either by the irritation chemicals or the allergic chemicals are there. If we will touch or contact with that, we will have that. So these effects like scaling, eczema, acne, pigmentation changes, ulcers, as well as the neoplasia. Some other chemicals are also there, they will pass through the skin. They may be aromatic amines like aniline and solvents like carbon tetrachloride as well as the benzene. So the toxic or potentially toxic agents that may be inhaled into the respiratory tract, and thereby their localized effects will be appear, like irritation with the ammonia as well as the chlorine gas, and also some inflammation we will see that, and necrosis, and finally ultimately it is cancer. Some examples of the industrial toxicants like the carcinogens, that exposure is largely because of the lifestyle. So it is very surprising fact that cigarette smoking, but occupation is an important source of exposure to carcinogens. Cigarette smoking is also one of the important factor for the getting the cancer. And another metal is the cadmium. So the accumulation of this toxicant, especially the biological half-life of up to 30 years in humans. So more than 70% of the cadmium in the blood is bound to red blood cells, and accumulation that occurs mainly in kidneys and liver, where cadmium is bound to the metallothionein. So in humans, the critical target organ after long-term exposure to cadmium is kidney. So with the first detectable symptom of kidney toxicity, that is increased excretion of specific protein. And next is chromium. It is also most important chemical that results from compounds of hexavalent chromium that can be readily absorbed by the lung as well as the gastrointestinal tract. And some lesser extent we can see that it can be absorbed by the skin. So the occupational exposure to the chromium that causes the dermatitis, ulcers on the hands and arms, and perforation of the nasal septum, and also inflammation of the larynx and liver and bronchitis. So the chromate is carcinogen, which is causing the bronchogenic carcinoma. The risk of chromate plant workers normally suffering from the lung cancer is 20 times greater than for the general population. So the compounds of trivalent chromium are poorly absorbed. That means it depends upon the which state of chromium is present. So it is not a cumulative chemical, but once it is absorbed, it is rapidly excreted into the urine. And another chemical is benzene, that is used extensively in rubber industry as a solvent for the rubber latex in the later half of the 19th century. So the volatility of the benzene that made is so attractive to the industry and also caused high atmospheric levels of the solvents. And another important toxicant is asbestos. Everyone knows about the asbestos. So asbestos and also the other associated fibers of naturally occurring silicates, we know that they will separate into flexible fibers. So asbestos especially is the general name for the group of fibers. So the usage of the asbestos that has been extensive, especially in roofing as well as the insulation. So and also asbestos cements and brake linings and electrical appliances and also the coating materials. So it is a respiratory disease normally caused by this asbestosis, is characterized by the fibrosis and then calcification, as finally it is lung cancer. So in humans, not only is there a long latency period between the exposure and the development of tumors, but other factors are also influence the development of lung cancer. And we have seen that the cigarette smoking, just we have discussed, that is enhances the tumor formation. And recent studies also shown that stomach as well as the bowel cancer that occurs in excess of workers, those who are working in the insulation industry, which are they are exposed to asbestos. And the second type is known as use classes. This type of toxicants normally that what regularly we are using, that is the drugs of abuse, therapeutic drugs, agricultural chemicals, food additives, metals, solvents, and also the combustion products. And in this use class also, what are the chemicals which normally exposed to? They are not entirely, we can say that, synthetic chemicals, but many natural products are also isolated and are used for the commercial and other purposes. They must be subjected to same toxicity testing as required for the synthetic chemicals. Some examples of the natural products like insecticides, that is the pyrethrin, the clinical drug digitalis, and the drug of abuse, that is cocaine. And agricultural chemicals are also there, like insecticides, herbicides, fungicides, and rodenticides, in which the toxicity to the target organism is desired quality, whereas toxicity to non-target species is to be avoided. And development of such selectivity, the toxic chemicals, is one of the applied roles of the comparative toxicology. And also the clinical drugs, which are properly the normally call it as a pharmaceutical chemistry and also pharmacological department. And the third is drugs of abuse are the chemicals. They are taken for the psychological or the other effects, and they may cause the dependence as well as the toxicity. So many of these are illegal, but some are clinically significant when used correctly. So next toxicant normally in the use class is the food additives. They are of larger concern to toxicologists nowadays because they are toxic or being tested for possible toxicity. And some industrial chemicals are also, there are numerous chemicals are there that testing them for toxicity or controlling exposure to those known to be toxic is larger area of toxicological activity. And naturally occurring some substances are there. They are the phytotoxins and then mycotoxins and minerals, and all occurring in the environment. And combustion products. So there are numerous number of chemicals which we are use. That is the large as well as the important classes of toxicants are the generated primarily from the fuels and also other industrial chemicals. So the organisms which are not exposed to one chemical at a time, but rather they are exposed to mixture of chemicals, the composition of which changes normally come across. So common toxic mechanisms and also that sites of action is the enzyme inhibition or the activation. So a major site of toxic action once it is ingested into our body for metals is the interaction with the enzymes that leads in either enzyme inhibition or the activation. There are two mechanisms especially for the inhibition that may occur with the result of the interaction between the metal as well as the sulfhydryl groups on the enzyme, or sometimes it may be metal that displays the essential metal cofactor of the enzyme. And another important metal is the mercury. So mercury exists in the environment in three main chemical forms. One is the elemental mercury, and the second one is the inorganic mercurous and mercuric salts, and organic methyl mercury and dimethyl mercury compounds. So elemental mercury normally in the form of mercury vapors. It is almost completely absorbed by the respiratory system of human beings, whereas the ingested chemical mercury is not readily absorbed, but it is relatively harmless. Once absorbed, the elemental mercury that can cross the blood brain barrier, that is the BBB, into nervous system. If inorganic mercury, that may be converted to organic mercury through the action of sulfate, that reducing the bacteria to produce methyl mercury, a highly toxic form which is readily absorbed across the membranes. So there are several large episodes of mercury poisoning that have resulted from the consuming seed grain that is treated with mercury fungicides, or from eating fish that is contaminated with methyl mercury. So with all these inclusions of the metals, that is a natural as well as the use classes as well as the exposure class chemical toxicants. So we have studied what are the effects and then how we are using, which form we are using and which form we are exposed to. So, with this knowledge, I would like to conclude this session by that what makes a chemical substance toxic. That means the toxicity is the ability of any substance to cause harmful health effects. So, these effects that can strike a single cell, sometimes group of cells in an or otherwise some organ system or the entire body. So, depends upon the nature of that particular chemical. So, the toxic effect that may be visible damage sometimes or decrease in the performance or the function that is measurable only by test. So, all chemicals can cause harm at certain level. When a small amount that can be harmful, the chemical is considered to be toxic. So, when only a very large amount of chemical can cause damage, the chemical is considered to be relatively non-toxic. So, the toxicity of any substance that depends on the three factors. The first one is its chemical structure, the extent to which the substance is absorbed by the body, and the body's ability to detoxify the substance, that is changes into less toxic substances and eliminate it from the body. So, the toxicity of a substance is the potential of that substance to cause harm, and also only one factor in determining whether it is a hazard exists or not. So, any chemical that is determined to be toxicant and produces hazard depending on the toxicity. How much of the substance is required to cause harm, and what is the route of exposure, and how the substance enters our body, and also what is the concentration, that is normally we can call it as dose. How much enters into our body and how long, that is a duration, that the length of time we are exposed to, whether it is a single exposure or multiple exposures, and exposure to single chemical or group of chemicals, and also the individual susceptibility, how our body reacts to the substances. Normally each and every individual will not respond in the same way. So, when if we compare to the other individuals, some chemicals are hazardous and some chemicals are not. So, individual susceptibility is also most important. In general, the greater the amount of substance that enters into our body, the greater is the effect on our body. So, this connection between amount and effect is normally called it as dose response relationship. For example, solvents like toluene, acetone and trichloroethane all affect the brain in the same way, but to different degrees at different doses. So, the effect of these solvents are similar to those that results from drinking alcoholic beverages. At a low dose, you may feel nothing or mild, sometimes pleasant, or sometimes it is a sensation. A larger dose may cause the dizziness as well as the headache. With even a larger dose, you may feel as if you are drunk or pass out or even stop breathing. So, when you inhale a toxic chemical, the dose you receive, that is depends upon the level, that means the concentration of the chemical which is present in the air, and how hard, that means you are breathing, that depends upon your degree of physical exertion, and how much of chemical that is inhaled that stays in our lungs or it is absorbed into the bloodstream, and how long the exposure lasts and how long is too long. So, that depends upon the hazard or the toxic effect it is exert on the human body. So, with this I would like to conclude over here, and then in the next session we will see that how the consumed toxicant will be detoxified. Thank you.